Hello guys, I'm Sapro Alivaya, welcoming you to my episode of Fill the Code. In my previous video, I said about understanding each line of code and be curious that what each line does. So today my curiosity got me into this video where I'm going to discuss that end-to-end process of how a code is executed in our machine. Means from writing a code to how the outputs are being displayed in the screen. We are going to discuss each flow in the process in details. So I have divided this video in two parts. First part is how a C code means if we write a C code, so obviously we are saving that as a .c extension. Means let's say I have written a code and I have saved that in my machine as test.c file. So the first part is we are going to discuss how that test.c is being converted to test.exe. .exe means executable files, and executable file is a type of file which is being executable by our computer. In the second part, we are going to discuss about the roles of operating system and central processing unit in this whole process. And don't miss the end. No, I'll not say this kind of things in my video. I'm not here for lame clickbaits for reach. I just want to exploit my curiosity and I just want to give you the feel of code, and we'll try to come up with some such interesting videos so that you can also start to feel the code. Like अरिजीत सिंह के गाने जैसे फील करते हो ना, तो मैं चाहता हूँ कि कोड को भी ऐसे फील करो, तभी मजा आएगा. Okay? Today we are going to take example of this code. This is simple code to take two inputs, number 1, number 2, and just sum it up and add the value of 10 to the final sum. And why I have taken this has defined in this simple code, you'll got to know in the video. As I said, today the main focus is to feel the code, means to understand the whole process in details of how a code is being converted to .exe file, and then how our operating system and CPU is working and how it is displaying the final input in the screen. So mainly we got 4 steps for converting a .c file to a .exe file, means our C code to a machine executable code. And 4 steps are pre-processing, compilation, assembly, linking. So my main focus is to explain each and every step in detail, but I'm not going to give you the notes because you can take that from internet and I don't want to do repetitive tasks. So what pre-processing does? So pre-processing, it handles directives. Directive means the line starting with has. You can simply understand it like this. Has include. This is a directive. Has define. These are directive things. Okay. And this is going to handle macro expansion. What is macro expansion? We are going to discuss that in detail. And it is going to remove the commented code. Remove commented code. Because as we know, commented code is only for the reference of the coder or the developer. It is not required by the machine. Like what machine will do to know the comments. Okay. So what pre-processing does? Now why we are writing this has include stdio.h means something we want to tell the compiler or machine that okay, we have to include something. That's what the literal meaning of include. Na? And the second thing is what we mean by has defined max 10 means we are defining a variable kind of thing max, and the value of max is 10. So what has include stdio.h do is it includes some definition, like some header definition. So here if you see int num1 num2, this line is pretty clear. Machine will also understand that okay, num1 and num2 are two variables being declared, and this then comes the scanf. So now have you ever wondered that how machine is knowing that okay, what scanf should do, like where it is written that what scanf should do, where it is written what printf should do. So that's where this total process will come into picture and you will get to know at the end of the video. Okay, so basically has include stdio.h, it includes the definition for scanf and printf. Like just think it like this: scanf, then some like character star input kind of thing, and printf. Don't worry about these things. This will be clear at the end of the video. Okay. So scanf, printf, and as I said, why I'm saying at the end of the video means once we'll discuss all these things, you can relate. You can relate that okay, what I'm saying by this definition of scanf and printf means you should know that if something is we are writing in the code, then our machine should know that okay, that things are there. Means machine should know that okay, printf is a function and scanf is a function and these functions are present. So pre-processor what it does is it just adds the header like the definition of the function. This is the definition of functions, so that our machine will know that okay, printf and scanf is a kind of function and it's present, so that at least it will not throw any error. Okay, so this is one step. Second step is macro expansion, and what macro expansion means is here if you see max 10 is there. So max 10 means wherever max is there, it will simply replace that with value 10 because its actual value is 10, so that at least machine will not get confused that okay, what is max. From now onwards, machine will know that okay, the value is 10. There is like max will be not present from now onwards after pre-processing step. And the third step of pre-processing is it will just remove the commented code. So this commented codes will be removed from our code. So after this our code will look something like this. This will also remove only definition of head functions will be there, and this main function will be there, and in main function also these declarations will be there, and this scanf printf will be there, and this max will also converted to 10. So after this pre-processing step, we'll left with pre-processed code. Now the second step is compilation process. So once the pre-processing step is done, our code enters into compilation phase. So here compiler translates C code into machine readable code. Means basically you can say that our compiler will translate it to assembly language. And guys, assembly means obviously we know that if we are making a car, then in the assembly step we are going to assemble the wheels, the chassis, and step by step we assemble one by one thing. So that's what, like, assembly language means the set of instruction that our CPU or our machine should perform. Okay, so in the compilation process, our C code, so let's say our C code is test.c file, so it will be converted to test.c will be converted to test.s, which contains assembly language code. Okay, and we should not dive more details of all this, but just to give you a feel, I'm explaining it in a very high level. Okay, then assembly, what assembly step does is it will convert .test.s to test.o file, and what .o means it will convert it to object code, and object code contains binary machine readable code. And as I've said in first video that computer buddhu hai, computer only understands the language of 0 and 1, so, and that's what binary means, 0 and 1. So basically in our assembly step our code will be converted to object file. And the most important step, linking. What linking does is, linking means linking is been done by the linker, and what linker does is it will basically, in previously what I have explained that okay, int num1 num2 means variables will be declared. Then here if you see scanf and printf are there, and we have only given that definition for that function, but execution of that function is not there, not yet included now. So from somewhere we have to get this execution of the function. Means let's say if we are writing one function xyz and we are passing two variables, int a, int b, and this function is returning the sum of variable a and b. So, and in our code if we are calling that function like this, like xyz 10 20, then we will be in the c variable we will be getting the output 30. So here if you see we have this function now, and that's why when we are calling the function we are getting some output. So somewhere in the code this function should be there, but in our code this execution or what I guess the code for this function is not there. So that's what linker does. Means some developers are there, talented developers we can say, they have created a standard library, and in that standard library all these kind of functions, printf, scanf, and whatever kind of function we are going to use in the code, the definition and all the total code for that functions are there in the standard library. So what our linker does is, linker simply and one more important concept is there. Whenever our teachers used to explain us the code, they if we are declaring variable num1, they will say that okay, for num1 you can create the box, and the box is the memory where this num1 will be residing. So, and whenever we are saying that okay, we have to now initialize number 1 with 10, then in future if we are updating the value of number 1 from 10 to 20, means we are saying that we are just updating at the address of number 1. Means this is the what number 1 points to a memory location where some value is there, and number 1 has one address value, and from that address only will come to know how you will know that if you are in Bangalore. So if I have the address, I can go to that address and I'll find you now. Like that, number 1 has some address, and by pointing to that address we can access the value of number 1. So like this we are accessing anything in the code. So same for this printf, scanf also present in a memory location, these functions. So what linker will do is, linker will just in our code it will give the memory location for printf, scanf, so that when CPU will run this program, CPU will simply go to that memory location for printf. Like in a memory location this printf function will be there, so CPU will go to that location and it will execute that function, and it will if it is giving some output, then obviously that output will be displayed in the screen or whatever the work of that function, it will do that. Okay, so these are the main 4 steps. Okay, and then we are now jumping to the second part of the video where operating system and CPU comes into the picture. So in future video we will have one elongated session where we are going to discuss about the operating system and CPU in detail. So basically for now just understand that operating system plays important role in managing system resources. So obviously now guys, in our systems has limited resources. Means let's say we have RAM 8 GB of RAM. So 8 GB is limited, means we cannot simply assign 1 GB of RAM to a simple 1 KB or 1 KB of program. Okay, so what operating system do is it manages the system resources, it controls the hardware means our keyboard, mouse, monitor, all this, and it ensure smooth execution of program. These are the steps or the work of operating system. And what CPU does is, CPU simply performs the actual execution of machine instruction. and machine instructions are present in the .exe file. And I think I forgot one point, that after assembly step linking is there, and when linker done with its job, it will simply convert the O file to .test.exe file. So exe file will be used by CPU to generate the output. Okay, so now we are just going to see the detailed execution. Okay, so you created a C file, test.c. okay, and you have the code, like the initial code. As we have discussed, this initial code will be there in test.c file, and once we are running this program, so obviously there will be one location or the executable file .exe, test.exe. So what our operating system will do, so this code will be there in our disk, obviously in our storage. So operating system will simply move this from disk to RAM, and RAM means memory. Operating system will move this from disk to RAM, and it will set up the initial CPU, disk to RAM. It will set up the CPU and prepare the process for execution. It will prepare. Then CPU fetches instruction from the program. As I said, this exe file has machine readable code. So CPU will fetch line by line from this code, and CPU will start executing each line. And as this line is will be encountered by CPU will simply execute that line. So, and once our process ends, like return 0 is the termination of program. So CPU will simply terminate here, and the OS may clean up the memory allocated for the program, close any open file, and perform other termination tasks. But you must be thinking that, okay, while running this program, earlier I have discussed that, okay, linker will simply give the address for the printf and scanf functions. So when this linker will be resolving this address. So now here, if you see in our RAM, this is, let's say, memory. This is, let's say, RAM memory, where our program is there. Each line is there. Machine code, that instruction will look something like, let's say, printf is there, scanf is there, then again printf is there. Let's say this is scanf, and this is for input A, this is for input B, and printf is for displaying the input A plus B. Okay, so now just understood. Okay, first, as I said, operating system will move the code from disk to RAM, means it will take the code from disk to RAM, and till now the actual implementation of this printf and scanf are not there in RAM. And once our CPU encounters, or our system encounters the first line where we need the external function, like scanf is external function, it will load the child library code into the RAM. It will load the child library code. So basically this child library code will be loaded now into the RAM, means that you can simply think like this: printf, scanf is being loaded into the child library, and let's say printf resides in the address 100, scanf in the address 200, and the execution, like the total code for these functions, are at this particular address. So when our machine will encounter scanf, so it knows, like as I said, linker has given the reference for this function in our executable file. So it knows that, okay, I have to go and search in 200 for scanf execution. So once it encounters scanf, it will go to address 200 in the RAM, and it will start executing the function scanf. And when scanf is encountered, obviously inside scanf we have the logic that, okay, we have to take the input from keyboard. So our operating system work is, it will do a system, like obviously interacting with the hardware is the role of operating system. So it will do a system call. Operating system will do a system call, and it will take the output from keyboard. Let's say for variable A, you have given input 10 from keyboard. So operating system will take that input, and operating system will assign that input to the variable A, because it has initiated the system call. So variable A has value, variable A, in the location of variable A, it will put value 10. Then scanf for B. So now if you see, the standard library is already loaded in the memory, so it is in the cache memory. So it will not again load the memory. It will simply use it will simply go to the location, and it will execute scanf. So for a second time also, it will go to 200, and it will take input from as it is a scanf has to take input from hardware, so operating system will be involved. It will do one system call. It will take the input from keyboard. Let's say you have given input 20, so it will put 20 into variable B. Then we have to do some calculation. Let's say A plus B. So this calculation will be done by CPU. So CPU will do the calculation. 10 plus 20, value is 30. Then printf, and printf resides in address 100, and as I said, this child library is already present in the cache memory, so we don't have to load it again. So it will simply go to address 100, and it will execute printf. And what printf does, printf simply takes the output, and it will display the output in the screen. So again, the involvement of hardware is there. So operating system jumps in, and it will do one system call, and it will simply display the value 30 in the screen. So this is the whole process. So what I am telling is how we have to take the feel of the code. So from now onwards, whenever you are writing a C program, just feel it like this. Okay, if I'm writing has include stdio.h means somewhere in the program I'm going to use printf or scanf kind of thing, and for that printf or scanf the definition for that function will be included in the code, and that is being handled by this has include stdio.h. And if I'm writing has define max 10 means somewhere in my program I'm going to use the variable max where the value of that variable will be 10. Then if I'm writing int num1 and num2 means I'm just telling my system that we have to reserve a memory space for number 1. Let's say if integer is using 4 byte of memory, so it will simply give 4 byte of memory to num1 and it will simply give 4 byte of memory to num2. This is the work. Then scanf means obviously here I am saying that whenever this scanf will be executed by my machine, it will operating system will jump in, operating system will do one system call, it will go to keyboard, it will take the input from keyboard, and whatever input is there it will simply go to location of number 1 because we have given ampersand. Ampersand means we are referring to the address of num1, so it will go to address of num1, it will put the value whatever we have taken from keyboard and it will put that to num1. And then scanf num2, so it will take the input of num2 and it will simply put the input of num2 to the address of num2. So let's say we have taken 20, so it will put 20 here. Then if sum is there, so CPU will be doing the calculation for num1 and num2, and then this max value is like obviously our preprocessor has converted to 10, so it will take num1 10 plus num2 10 plus this max value is 10, so 10 will be there. So CPU will calculate the final value to 40, then printf is there. So again this is a hardware involvement is there, so OS will do one system call and final output is being displayed in the screen. And if return 0 is there means this is the ending of our execution. So CPU finishes the process of a last set of instruction because this is the last set of instruction, and obviously for running of this program our operating system has assigned some memory. So this program is done, so it will just free up this memory and closes any open files are there, or it will just do the termination task. So like this whenever you are now writing a code, you should feel that okay, if I am writing a code now, if I am saving that to let's say test.c, so while compilation first it will be converted to test.s which is assembly language, then it will be converted to test.o which is machine readable object file. It contains binary code only 0 and 1, and then finally after linker, and linker will be giving just a address means the reference of printf, scanf like the external functions, and finally linker will convert this to test.exe. And once this test.exe is there, now from here you can take the feel that okay, now if I have hit the run button, so now my file is being converted to test.exe. Now operating system will find this file and operating system will move this file from disk to RAM, and RAM is my memory, and operating system will assign some memory means operating system will give a appropriate environment to run this code, so it will assign some memory for this test.exe file. And once this file is there in my memory, CPU will start executing line by line, and CPU will start executing line by line. So like int a and b is there, so obviously CPU will know that okay, I have two variables, int like integer kind of variable a and b. Then if we are encountering scanf means okay, CPU will know that okay, now one scanf is there which is the external library, so it will go and check in the memory. So obviously in memory for first time scanf will be not there, so operating system will load the memory, like load the standard library into the memory, then obviously scanf can be executed from that actual address. Then once our and if then you can think that okay, now operating system jumps in and operating system does one system call. So if we are giving an input in the keyboard, then that input, like if you are giving 10, then you can visualize that okay, that 10 is now going into the memory location for number 1 and it is staying there. Then if we are giving the value for number 2, then obviously that 20 is going into the location of number 2. Then if the next step is the calculation, like number 1 plus number 2 plus 10, so obviously CPU will be doing that calculation, number 1 plus number 2 plus 10. Then finally once printf is encountered, again operating system jumps in and system call will be there, and finally the output 40 is going and printing in the screen. Then after execution of program, the last line is return 0, so here our execution should stop. So CPU finishes the last set of execution. Now the memory that is given for this program to run is being cleaned up by our operating system and our program terminates. So like this guys, we can have the feel of the code, like whatever we are doing, there is so much thing going under the hood. So if we have the curiosity and if we are understanding each line by line, then like you will be confident. For any line you will be like okay, what this line does internally in your subconscious mind, each step will run. And whenever you from now onwards, if you are writing any code, then you should have the process going in your subconscious mind. If you are writing scanf %d ampersand num1, then the process should go in your mind that okay, ampersand num1 means the address of number 1, and whatever value will be given by keyboard is now going and storing in the memory location of number 1. And if you are writing printf means your mind's like in subconscious, it will go like okay, now operating system is doing one system call and it is asking monitor to display whatever value is being calculated by CPU, like in for this sum. Or if we are simply displaying num1 means obviously operating system should just take the value of number 1 and it should display in the system. So guys, if you have any suggestion for the upcoming videos, just type that in comment section. And if you understood this video and if you got some feel about the CPU, operating system, and how the code works, what is linker, all this, you can just comment in the comment section. And if you want to summarize what you have understood, just add that in the comment section so that it will be helpful for others. And if you have any suggestion for me so that I can incorporate that in my upcoming videos, please feel free to add that in comment section. See you in the next video.